Hello guys, welcome to Dan's IT Network, and for today's video we'll learn about how to create a summary route. Okay, and this is a perfect network design for me to demonstrate to you how we can create a summary route. Okay, so on this portion, so this two router, they are communicating using a RIP. Okay, so if the RIP is enabled on this two router, then definitely is they can ping to each other. All right, while on this router, okay, well, it is not communicating using RIP. The thing that is enabled on this router is the static route. So I created a four static route on this router, and these are the static route that I created. Okay, the 1.0, 2.0, 5.0, and 6.0. So you notice that these are the networks. Okay, so that this router can talk to this network that are participating with RIP. Okay, and also on this router, there is a command that we input the default information originate so that the RIP would be able to communicate with the static, and the static can communicate with RIP, and everything is working on this network. Okay, we can actually ping from each other, and I'll show you. So we'll try to ping from this PC to this router, and the IP address of this router is the 7.2, which is on the 7 network. Okay, so I'll click the PC command prompt, and then I'll type here ping 192.168.7.2, and it's pinging. We are receiving a reply. All right, and just to show you on this router that we did truly, okay, activate this static route, and let me show you then. I'll type here enable to go to the privilege mode, and then I'll type here show run. Okay, there you go. I put the four static route. Okay, the 6.0, 5.0, 1.0, and the 2.0. Okay, that is why they can ping to each other. Well, we have other option, okay, that we can do instead of putting them line by line. Okay, what if we have, let's say, 100 networks in here, and what we're gonna do is we're gonna type them line by line, right? And that is too much work to do. So that is why we do have the next option to create a summary route, which will summarize all of them. Okay, and we're gonna do that. Okay, so looking in here, so we have here the four networks. Okay, the 1.0, the 2.0, 6.0, and 5.0. Okay, and on this part, this is the formula that we need to follow. Okay, to get the magic number, and for us, of course, to create a summary route. This formula will definitely help us. Okay, and down here, this is the binary that we're going to use. Okay, because each IP address is composed of a 32-bit binary. Okay, and each portion it has a 8-bit. So this one has a 8-bit. This is 8-bit, 8-bit, 8-bit. So that is why this was divided into a four. Okay, a four octets. All right, 8-bit and 8-bit. Okay, and down here, this is the subnet mask. All right, but anyway, though, let's go first to this network, because we need to create a summary route to summarize all of this network IP addresses. Okay, to do that, first thing that we need to do is we need to look on their number on the first portion. Okay, so you notice that they're the same. They're starting on the same number. So 192, 192, 192, 192. And then since all of them are the same, then we'll write it down here all once on this binary. Okay, since they're the same. This is the pattern. Okay, well, if you'll try to look on other video tutorial on YouTube, okay, you'll find there that if they are trying to create a summary route, is each IP address is they will convert it into a binary. Okay, all of them, and then after that is they will look for the last common bit. Okay, but on my way, okay, I found a way. It's for me, it's much more easier. Okay, to how to create a summary route. Okay, and I decided to share this on this video tutorial. So this might help you, in passing the CCNA exam. Okay, so again, these are the network that we need to summarize, and as I mentioned to you a while ago, that they're they have the same number in the first portion, so we just need to write all of them once. Okay, all once on this 8, and then also going down, we need to write their the subnet mask, which is 255, because we do know that if these are all ones, this is a total of 255. Okay, why? Well, it's because if I will match this number, okay, this formula onto this binary, okay, so this is the 1, 2, 4, 8, 16, 32, 64, 1 to 8. If I will add all of them from 1 to 8, 64, 32 up to 1, you'll get a total of 255. Okay, so it's 255. And same thing on the next portion, the 168. Well, they have the same number as well. Okay, so we'll do the same thing. We'll write all ones in here, 8 ones, and we'll write here the 255. Okay, all right. And however, on the next portion is they have a different number though. This is 1, this is 2, this is 6, and this is 5. And you notice that the smallest one is the 1, and the highest one is the 6. And now then we're going to use this formula. Okay, we need to identify then the magic number. Okay, so again, the smallest one is 1 and the highest is 6. So by looking at this number, well, I highlight the number 8, okay, as the magic number. Well, why? Well, it's because if we will use this 4, then it's too little, all right, to cover this 1 to 6. Okay, and we can use the 16 as well, but it is not practical, all right. It's too much to this 1 to 6 number. Okay, and in Cisco CCNA, we need to locate the closest one. All right, so that's why we pick 8 as the magic number. Okay, so remember this magic number. Okay, and then the next thing that we need to do is we need to match this formula, okay, on this portion, because on this portion is this is where we you know we decided to locate the magic number, because the numbers are different, so we need to go onto this portion then. Okay, and we need to locate the magic number 8. All right, and we do know that if we'll match this formula onto this portion, this is the number 8. Okay, so it's 1. Okay, this is the 1, 2, 4, 8, 16, 32, 64, 1 to 8. Okay, so this is the 8. And then what can happen then is since this is the magic number, then the rest of the number going to the right, okay, should be all zeros. All right, so that is why I put them in here 0, 0, 0, and definitely in this portion they should be all zeros. Okay, and also what happened to the subnet mask is well, since these are zeros, okay, so the 4, 2, and 1, okay, so we did not include them, so we're just gonna need to add the 8 plus 16 plus 32 plus 64 plus 1 to 8, okay, because they are the all ones, and if you'll add them, you'll get a total of 248. Okay, and definitely on the last portion they should be all since they are all zero, then obviously it's 0 in here. Okay, so now this is the subnet mask that we will be using then. So now let's create the IP address. Okay, so let's create the IP address that will summarize then all of this network. So I'm gonna write this. Okay, so you notice that we just need to count the the to write the number that are the same on this IP address. Okay, so the number or numbers that are the same is the 192. Okay, and then dot 168. Okay, but in here, since on this portion, this is where we identify that, we decided to use the locate the magic number, then we need to um, make this 0. Okay, and definitely we need also to make this 0 as well on this last portion. Okay, because they are all 0. Well, we made this 0 on this portion. It's because that we need to use then the magic number on this portion. Okay, and to do that, since we chooses the number 8 as the magic number, meaning is the network will go up by 8. Okay, so to create another network, it needs to go up by 8. All right, so this is already a network though, but if we need to create another network, it needs to go up by 8, which is on this portion. Okay, all right, so I'll do that. 192.168.8.0. Okay, and now this is the first network, and this is the second network. Okay, and now let's identify though what are the available hosts that we can use on this IP address. Okay, let's do that. So I'll say 192.168. Definitely the first host on this IP is the 0.1. Okay, and this will be up to well, the range would be 192.168. It will be up to 7. Okay, well, we cannot use 8 because, as I mentioned to you a while ago, this is the next network. All right, so it should be 7, and the last available host is the 254. Okay, and I'm just gonna copy this, and then the very last one, okay, last host that is available on this network IP address is the 255. Okay, so this is the broadcast IP. Well, if you do know how to subnet a network, so it is just like we're doing a subnetting. All right, when we are trying to create a summary route, it is just like we're doing subnet. So if you're familiar in doing subnetting, then this is just easy for you then. Okay, all right, so these are the available networks that that are on this IP address. And if we'll try to look on this IP, okay, from 1.0 up to 6.0, you notice that we can actually find them within this range. Okay, we can find them. It's because on this range, it starts with 0 up to 7. And on this IP, it just starts with 1 and then just up to 6. So definitely all of this IP address are within this range. Okay, so definitely is we can use this IP as the network IP address. Okay, all right. And next thing that we need to do is we need to define what is the slash number on this IP address. And that's easy, right? We're looking on this binary, okay? So we just need to count the ones starting from the left, okay? So we just need to count them. So this is 1 up to 8, okay? And then 16, and then 17, 18, 19, 20, 21. Okay, so this is a slash 21. Okay, and we do know that if it's a slash 21 though, okay, which is on this is the magic number 8, right? If it's a slash 21, then meaning that the magic number is 8 on this portion. Okay, all right, so now that we're able to identify the network IP address, which is this one, then we need to use this subnet mask then. Okay, so I'll put this in here, and then I'll copy this. Okay, and let's go back onto the network design. Okay, all right, so now since we have now a summary IP route, just gonna put it in here, and there you go. Okay, so the IP summary route is created.